In this module we're going to talk about examining log files. Now if you're troubleshooting a MongoDB issue, be it performance, be it some sort of quirk in terms of operations, something that is unexplained, quite often your first stop is going to be the log files, and should you ever come to MongoDB with an issue looking for our help, they are usually the first thing we'll ask for as well. All of the MongoD and MongoS processes output log files, so when you're starting up a MongoD and a MongoS process, particularly if you're not installing from a package, one of the things that you have to specify is the log path for where you want to put those log files. You have to have the right permissions to write into them and everything else. For example, in Ubuntu, I believe it's simply varlog mongodb.log. It could be mongodb.log as well. There's a few other potential locations for it. In our test stuff, if we refer back to that for a second, in our test environment, we had our MongoS looking here. You can, in any given process, you can use the command show log, and that'll take the most recent log entries out of RAM. And this is a MongoS, so we'll get into what some of this means later on. But you can run show log on any of these processes. I think earlier on I connected to a MongoD directly. Let's do that, and let's do show log here. You'll see it's a little bit different. So you can do that on any running Mongo process to see what the logs are. It's pulling them from RAM, not from a file, so available, somewhat limited. It's only the most recent log buffer that's kept in RAM, so that the whole thing is, once it's flushed to disk, it'll no longer be accessible. But it is a handy way just to get the last few lines of the log without going out of the MongoDB prompt itself. That's tip one. Tip two would be when we're using our test options. So when I created this test cluster that I've been using throughout the module here, I did it with the sharding test command, which was illustrated in an earlier module, right? And I created it with 3 shards in replica set mode, single MongoS, etc., etc. And what you'll see here is that these look like normal log files, and they're scrolling by. There's still stuff going on this cluster. What you'll notice is that prepended to each log line, which can be somewhat hard to see on these when we have to zoom in so much to make it legible. But prepended to every log line, there is a port number, so M31300. So that refers to the MongoD process that's running on port 31300. M30999, that's our MongoS. So if you can keep straight in your head what the various port numbers are, 31200 is another one of the primaries, 31300 is another one of the primaries, 30999 is the MongoS. Keep those straight in your head, you'll be able to figure out what each one of these is, and when you're parsing it later, it makes it easy enough to figure out what this is going. But this is basically being piped into standard out. In other words, it's being printed to the terminal, known in Linux and Unix circles as being printed to standard out rather than going to a file. We could redirect this to a file, and then we'd be able to examine it there. And that's what most people are going to be doing. They're going to have each one of these, so the MongoS log, a MongoD log, going to individual files on their machines. And when you're troubleshooting an issue, you usually go to the most recent log. Hopefully you've got many days worth to actually go back and see what your normal usage pattern is, that sort of thing, for comparison. But on a busy cluster, logs can be very large, and in general logs can be cryptic. I will say this, that it is an ongoing effort within MongoDB to make the logs better, less cryptic, sort of in a more standardized format, so they're more easily parsable. So for example, in 2.6 we're making some improvements to how we log dates and times of entries in the logs. In previous versions we've improved the relationship between connection messages and actual work being done on those connections, right? So you could actually do one for one there and trace the lifetime of a connection through the logs and what was done on that connection and that kind of thing. So those are improvements that have been made in the past, and we're going to continue those improvements into the future. But nevertheless, the logs can be very large. On a busy cluster, you can have literally gigabytes of logs to look through. The nice thing is though that they do compress well. So if you zip up tar, gzip, bzip2, any of those common compression tools will be able to significantly reduce the size of a MongoDB log file. There's a lot of repetition, which is what we're about to see. So they can be cryptic. There will be lots of noise in the logs, right? So we're logging every time the connection comes in. We're logging every time something happens, usually, anything interesting at least. And that's the kind of thing you have to do to pick up on issues, to pick up on problems. You need a baseline of what a normal system looks like before you can really judge what our system in trouble looks like. So what we're going to be covering here is a few sort of tips and tricks, tools that you can use to more easily parse log files, to strip out the bits that you don't need to look at or that you might want to just put to the side for a while so you can better examine things. In a subsequent module, I will cover some more automated tools that give you graphical options and things like that. But for now, we're going to do some tips and tricks based around the command line to help you more easily parse out a log file and determine what's actually going on.